what we could work on. You know, in this section 3.3 that I tried to go into last time, turn on this thing and take a little bit of this homework. What I'd like you to know, though, is the main thing to me in 3.3 is know those 6. I tried to give you 6 basic functions to know. I called it a library of functions. So I'd like you to know those. Now, how I asked those, I'm not sure. The first question in 3.3 asks you this, and so what I asked you to know was the basic function y equals x cubed. Now, I don't know if you've memorized it yet, but I had it memorized as this sort of nice snake shape here, or whatever you want to call it. You could plot points to convince yourself, but that's good old y equals x cubed. And I'd like you to memorize that. Now, they've modified it, right? So they have this negative 3x cubed. So I didn't really get into to all the details of how this negative 3 might affect it. Maybe you know. Maybe you could speculate. The truth is, I feel like that's kind of coming up next chapter, but they slipped this question in here. Can I say this? I think the negative sign, what do you think the negative sign does to this graph? If I throw a negative sign in front of this graph, what do you think it might do to it?
Invert it.
Yeah, flip it upside down, or invert it is a good word, but yeah, the negative sign in front of any graph should flip it upside down. Now again, I think that's officially in chapter 4, but we kind of learned that with parabolas. You know, the parabola either opens up, but the negative sign in front flips it upside down, kind of, so that's not too bad. The 3, what happens when you multiply by a 3? What do you think that does? And I don't know how well I ever mentioned that, but it stretches it. Again, back to the parabolas, when there's a 3 in front of those parabolas, they're a little skinnier. When it's a 1/3 in front of those parabolas, they're a little wider. So when you multiply by 2 or 3 or 4 or 5, it's kind of like you grab it and stretch it and make it a little skinnier. So what do I have here? I have an upside down, skinnier version of this. And so I know all that based on memorizing the basic shape and knowing a little bit about what the negative 3 does. You know, if you don't know that, what do you do? Maybe you plot a few points. Plug in a 0 and you get 0. Plug in a 1 and you get negative 3. You guys okay with that? It's easy. 1 cubed times negative 3. Plug in a negative 1 and you get negative 1 cubed, which is negative 1 times negative 3. So then you get a positive 3. And that's kind of the result of all that stuff we just said. It goes through 0, 0. At negative 1, it was positive 3. Is that what I'm saying? Yeah. At negative 1, it was a positive 3. At positive 1, it was a negative 3. So it is kind of this upside down version of this. So anyway, you can plot some points and create some graphs like this. How do I use their graphing tool? Click to, let's see, what do they want me to do here?
Click that button, I think.
And okay, then which graph should I grab? I guess I should grab this cubic thing, shouldn't I? And then I need to plot a point, like negative 1, 3. And maybe 0, 0. And maybe 1, negative 3. I know it's boring to watch me do this. come it's not coming out too good?
Maybe on the point. 4 point.
I need another point maybe?
Yeah.
If I plug in a 2, what do I get if I plug in a 2? Plug in a 2.
Negative 24.
Oh wow, right, I get 8. Right, 2 times 2 times 2 is 8. Times negative 3 is a negative 24. If I plug in a 2, I get a negative 24. I can try that. 2. Oh, this is looking good now. Yeah. Oh yeah. Thank you. Yeah. So plot enough points, and you can use their graphing tool to graph it. Huh. Okay. That was fun. Again, here's one. For just a second, ignore the 3 if you would, but whatever. What we have here is what I tried to teach you was y equals x to the 1/3. Now, I didn't call it that originally. You know what 1/3 is. I did teach this last week, I think. That 1/3 power actually is a cube root. And the cube root graph, I guess, is one I asked you to memorize. It's actually the cousin of him. And what I mean by that is it's the sideways version of him. It's sideways and it's sort of flipped over. It's this. So that's him. Of course, if it's multiplied by 3, then it's stretched a little perhaps. But just based on that common knowledge, I wanted you to memorize 6 basic functions. I think maybe I can get this one. It's an x to the 1/3. It's not flipped over or anything. It's just should be this. And the funny thing is, I guess you could get confused between B and D. Which one would you say it is? Well, it's this. See, remember the other thing we discussed last week in 3.3 that was kind of interesting is how this power affects things. You know, when this power is a 3 or a 2 or a 4, you got this concavity coming this way. It's concave up. It's really going to grow, increase quickly. When you have this power less than 1, 1/3, 1/2, 1/5, 2/5, 2/3, when it's less than 1, that concavity is concave down. It grows, but a lot at a lesser rate. It's not growing so steep. So it's concave this way. So maybe that piece of knowledge helps. I mean, it's illustrated in these examples, but we sort of illustrated it in general. Anyway, I think it's B, don't you? Good job. Good job, good job. See, here's another one. I wanted you to know this basic graph. I wanted you to know y equals the square root of x. And so maybe you took the time to memorize it like I asked. It's this. It's sort of a half of a sideways parabola. Again, because it's x to the half, that's what a square root is. A square root is x to the half. We've got this concave down look again. So a lot of little connections here, but what happens when they add 3 to it? Again, that's something in a way I didn't discuss. I feel like that's coming up next chapter, but can you use any logic?
It's the y-intercept, so you just pick the graph that has.
Oh, he's thinking about it as the y-intercept. I mean, however he thinks, if he's thinking, maybe he's thinking about plotting a point real quick. If you throw in a 0, you get a 3. He's right. That's the y-intercept. So another way to think is it shifts the whole graph up 3, which is what it does. It takes this graph and pushes it up 3. So good. I want you to know some basic graphs, but then you have to maybe plot a couple points to get what they want. I'm thinking C. Don't you think C?
Yeah.
Okay. I wanted to do some of the more difficult homework, but this is fun. This was this graph. I mean, again, I taught you these things but I never added 4 to it. This graph was this famous 1 over x is this famous graph. It's undefined right here at 0. It's got an asymptote. So that's y equals 1 over x. That's in my library of functions. There's 1, 2, 3, 4. I guess there's a couple more. There were 6 things in my library of functions. But anyway, what did they do to this one? They added a 4 to it. By the way, that's not a y-intercept because on this graph, there is no y-intercept. It's undefined at 0. It's still undefined at 0. The last problem, I said, let's plot a point. Let's plug in a 0. On this problem, I can't plug in a 0. If I plug in a 0, it's undefined. I could plug in a 1. If I plug in a 1, I get 1 over 1 plus 4. I get a 5. If I plug in a 1, I get a 5. I wonder if that looks like anybody. Kind of looks like this one. If I plug in a 1, I get a 5. I mean, basically, isn't this D? Doesn't D look like my graph pushed up 4? Again, that's what that up 4 is doing. That's what that. So I think it's D. I don't mean to help you with all your homework. Let me see. We talked about these piecewise functions. I might need to help you with some of this. Can you guys do this one? Okay, I'm going to shut up. Can you tell me the answer? If I just shut up. A, B, C, or D. You shout it out. Kind of hard. These graphs aren't the best looking. Maybe I should move down a little bit. But when x is between 0 and 3, see, with these piecewise functions, I tried to teach you to look over here. When x is between 0 and 3, the y value is 4. So I don't know, maybe that's here. 0 to 3, the y value is a 4. This is not labeled too good. That's 4, 8, 12. Yeah, this is good. That could be it. That sort of could be it. I don't think these things are slanting. These things they're 4, 8, 12, or 16. You with me? They're just horizontal lines, So it's not this one. They are growing. It's not this one. This one is 16, 12. This one's coming. So it's either A or B. Wow, you know what the difference is?
The dots.
The damn dots, yeah. So at 0, it's supposed to equal the 4. I mean, when x equals 0, it's 4. So when x equals 0, it's 4. The dot should be colored in. On this one, when x equals 0, it's not 4. See that open circle? Yeah, cool. I'm happy. I think it's A. Subtle little difference between A and B. Subtle little difference. I'm just moving on though anyway. Just a little more of this. This one's kind of funny. I might help you Thursday if I need to. What's nice about this is that this one gets more complicated, as you can see. It's a piecewise function. It's defined in a couple of pieces. But they're not asking me to graph it. If they're asking me to graph it, it's a little more complicated. They're not asking me to graph it. I think they just want these values. Look, they want f of -2. Well, that means you got to plug in a -2. And that means, again, like I've tried to say, you better read these directions first. These directions say if x is less than or equal to 0, please use this piece. If x is greater than 0, please use this piece. And if I'm trying to do f of -2, then x is -2, and that's obviously less than 0. So I should take that -2 and I should plug it in there. It's just a matter of reading those directions. Anyway, so it's easy. -2 squared is 4. 4 minus 5 is -1, I think. They also asked for f of 1. Well, that means x is 1. If x is 1, we're greater than 0. I should plug a 1 in here. 1 cubed plus 1 is 2. I mean, This is easy part. Reading the piecewise functions and knowing how to plug in some values. But please read the directions, kind of.
So do you vote for the numbers?
Well, so I did those. I mean, that question was that. That question was that. I can go. I've done them. There they are.
Which one do we answer?
Well, both. Well, here.
Just the first one?
Well, let's see. So f of negative 2 is 1, right? So I'm going to put a 1 in there. Uh-oh.
Was it a -1?
Oh, was it? Oh, it was -1. Sorry. I'm plugging in a -2. Thank you, sorry. -2 is 4 minus 5. It is a -1, right? Sorry. Thank you. So if I type in a -1, that should work. -1. Woohoo! And then they want the other one. Yeah. Then what was the other one? A 2? We decided it was a 2. Hopefully I get this one right. Cool. Is that all they want? That is all they want. Good. Now this is easy if you've memorized, if you remembered my little lecture. Concave up or concave down. It kind of refers back to this. You have an x to the 3/5. You don't even have to really worry about the 3. You have an x to the 3/5 in the first quadrant. What does it? Is it concave down or is it concave up?
Yeah.
It's concave down. How do you know? Because the power is 3/5. And when a power is less than 1, that's the shape. When the power is more than 1, it's the concave up shape. Right. Right. That's it. Just gotta memorize that little rule. A few more of these. These are all good questions here. There's some more. Guess what? I didn't do any of this stuff. I'm just going to turn off the screen here. Let me just turn that off a second. One thing I didn't get to, right, and I'm not sure if this is going to make the test at all, but it's in your homework, and I'm not going to take it back out of your homework. It's in there now, and it's an absolute value equation. You know, if the absolute value of x equals 6, how do you solve an equation like this? Well, it's very logical. We barely discussed absolute value one day, but this is very logical. Look, for this to be true, x has to be either a 6 or a -6. I mean, it's real logical. You can just see it, can't you? If you know a little bit what absolute value means. So that's the answer. X is a 6 or x is a -6. Both of those answers, if you plug them in, give you work. Okay, so what if it's a little more complicated? 2x minus 7 equals 13. Well, then you kind of do the same procedure, but it's very logical. I'd like to explain the logic. Here it is. You know, for this thing to come out to be 13, what's inside the absolute value, the 2x minus 7, has to either be a 13, or what's inside the absolute value has to be a -13, right? If this was a 13, it would come out to be 13. If this was a -13, it would come out to be 13. It's very logical. So the steps for solving an absolute value equation involve kind of taking it out of absolute value, setting it equal to 13 or -13, right? And then you solve these little equations. And maybe you remember this from intermediate algebra or something like that. It showed up in this section, and to me it's a little out of the blue, but I assigned a few problems. Let's do it. If I add the 7, I get 2x equals 20, and I get x equals 10. Some people just assume that the other answer is -10. That's wrong. Hold on. It was true up here, but not here. And here you got to do the math. Add the 7. See, when you add the 7, you get -6. When you divide by 2, you get -3. So these are the two answers. They're not like this, +6 and -6. You start off setting it equal to positive 13 and negative 13, but when you do the algebra, you get a couple of different answers there. Cool, but they're easy. Maybe you want the test to be full of these, but I'm not sure if these, they're in the homework just barely. They kind of don't flow with the rest of the chapter, I don't feel like, so I'm not sure. I don't think they make the test. But have success on a few homework problems. There might be some tougher ones. That one looks kind of good. I would do the same procedure. Here's another thing I didn't discuss. And I'm not sure how this makes the test. Let's do, this is just a different topic here. There's only a couple of these in the homework. I'm not sure. I might just exclude this from the test too, but I'll just leave it in the homework. It says, this is a sentence that says, y varies directly with the square root of x. Well, when you read a statement like that, y varies directly with the square root of x, and they wrote the words square root of x. So that statement you can write mathematically. And when something varies directly, here's what you do. You write, this is kind of new, we haven't talked about this. You write y equals, and then because of the variation or the direct variation, you introduce a constant called k. K is just some constant of variation that's multiplied there. And so what is it? And so it's varying. There's the constant k of variation. What's it varying directly with? The square root of x. So it varies directly with the square root of x. And that's what that statement in English is. Here it is written mathematically. That's direct variation. I think there's another problem where they use the word inverse. Inversely. Watch this. If it varies inversely, so this was varies directly, and that's how you set it up. If it varies inversely, same problem, watch. You set it up like this. You still have y equals, you still introduce a k, but since it varies inversely, then you divide by whatever it varies with. The square root of x, okay, the square root of x. So direct variation is multiplied through some constant k. Inverse variation is divided with some constant k involved. Then what? It says, when y is 6, x is 4. So they tell me this sentence, I write down this, I just lectured you on this in case we run into another problem, but let's abandon this for now. Now they say, when y is 6, x is 4. Okay, well that's nice. I guess I could plug that in. If I do plug that in, what does that do for me? If I plug that stuff in, what can I do with that? I can find k. If I plug in a y and an x, like they've given me, I can find k. All right, that's what I'll do. Let's see. If I plug in y is 6, y is a 6, I don't know the k, the square root of x, and they said x was 4. Oh, okay, yeah, let me work on this a second. That's a 2. Square root of 4 is a 2. Divide by 2, k is 3. Okay, k is 3. So instead of a sort of a generic variation problem, now I kind of have a specific variation problem. If I rewrite this, I can write y equals, instead of k, now I know that k is 3 times the square root of x. And then hang on, there's one more, there's actually a question now finally. Find x when y is 18. The question is, find x when y is 18. And now you can do that. But you couldn't really do that before because why not? Why not? Find x when y is 18. You couldn't really do that before because you didn't know k. So they gave me a piece of information. I plugged it in. I found k. Now I can answer their question with this specific. Now that I know k, I can answer their question. Let me try this. If y is 18, can you actually find x? You're doing algebra, you're doing a little solving. I would divide by 3. And I don't even know if this algebraic step has come up, but you're smart students. If you're trying to get the square root of x, if you're trying to get x and it's buried in a square root, perhaps we should square it. So we grab this side and square it. We grab this side and square it. Or we just use logic. What is x? 36. Cool. That's kind of wild. That's sort of a 3-step problem, that variation problem. Look, one more time here. They give me this sentence. So step 1 is, okay, take the English sentence and write the math. So that's kind of step 1. You got to get the equation set up. Whatever they wrote, whatever they said, you set up the equation. Step 2, they give me a couple pieces of information. Oh, good. Plug those in and you can find k. That's sort of step 2. And then step 3, here, we got a question for you here. Please find x when y is 18. So then you can do that. You with me? It's one question, but it's sort of got these 3 steps. Write down the equation, take some given information, find k. Once you find k, you can answer the ultimate question they were asking. So this 3-3 had, so just now, the last 10 minutes here, I messed around with absolute value equations, and then I messed around with this variation a little bit. I didn't get to that last week. So that'll help you a little with your 3-3 homework. Again, how does that show up on the test? I haven't quite decided. I don't know if it shows up at all. I'm not too enthusiastic about these topics. But I'm more enthusiastic. I like the variation a little bit more than that absolute value equation. So it may show up. You know, what's often a good preview for the test, but I'll definitely talk more Thursday about the test, but what's often a good preview for the test, you've learned perhaps, is that online quiz, right? That online quiz is sort of more similar to the test. So I'm going to be setting one of those up today or tomorrow, and I'll have some better ideas for you Thursday. Well, okay. I don't want to do any more of this, I don't think. And we're getting, I don't know, it's 8:30. I want to give you, I think today's quiz is a little longer. I want to give you time to work on these parabolas. So I think I want to give you a quiz. I'm going to hit pause.